There we are, we're on. Great recording, Emily. You're doing a fantastic job. Jordan, you're doing some great sitting there. Yes. Right. So, part A of question 4. Find the matrix that represents a shear with y-axis invariant, the image of the point 1, 0 being the point 1, 4. Well, actually, we know this, don't we? This is just one of those ones that we hopefully have remembered. That it's either 1k01 or 10k1. And the y-axis invariant, so the shifting across one. Now the up one, that's the top right corner, is it? Have I got this bottom left corner? I've got it the wrong way around in my head there. I haven't read the question yet. So this is the one with y. Okay, so it's going up that way. So it's just a case of writing down the matrix that we want. We know we've got ones out there and there, and it's that one. For this. It's just, this has got to be something that we remember, hasn't it? You can of course test it by multiplying a unit square just to make sure you've got the right one. But part B, describe fully the geometrical transformation represented by x. Well, we talked about this, so this is root 2 over 2, minus root 2 over 2, root 2 over 2. We refer to the formula booklet. And we remember in the formula booklet that we have a description of some transformations using matrices, one of which, well, we're looking for the one where the leading diagonal is the same and the other diagonal has a different sign. It's the one that goes cos theta minus sine theta, cos theta, and that one is anti-clockwise rotation about theta, about the origin. That's there in the formula booklet for us. Now, notice what we've got here. So cos theta, in our case, is root 2 over 2, and sine theta is minus root 2 over 2. So we want to find the value of theta that satisfies both of those two equations. Well, if cos theta is root 2 over 2, we get, if we do inverse cos on our calculator says pi by 4, or 45 degrees. Shall we work in degrees? 45 degrees.
Definitely work in degrees.
If we do inverse sine of minus root 2 over 2, our calculator doesn't say 45 degrees. It says minus 45 degrees. Now we have to work out which of those two answers we actually want. Well, because of the cosine graph, we know the cosine graph's doing that, isn't it? So when it's root 2 over 2, it's actually also that at minus 45 degrees as well. Whereas with the sine graph, the next time that's minus root 2 over 2, it's minus 45, but it's then way over there, isn't it, on 225 as the next value. So actually it's the minus 45 that's true for both of them. So this is 45 degrees. If this tells us an anti-clockwise rotation, we must be looking at 45 degree clockwise rotation in order for that to be true. So the rotation, 45 degrees clockwise about the origin. Is the answer that we want. And that's your 2 marks. Quite a few people got the whole clockwise, anti-clockwise thing mixed up in the midst of all of that. We then have part 2, which says find the value of the determinant of x and describe briefly how this value relates to the transformation represented by x. So the determinant, part 2, determinant of x is, it's quite an easy thing this to work out, isn't it? That's root 2 over 2 times root 2 over 2 minus root 2 over 2 times minus root 2 over 2. And what we've got there, that's a half. We've got 2 over 4 minus a half, and that one, it gives us a value of 1. And actually, because of what we already understand about what the determinant means, we could have expected that to be 1, couldn't we? We knew it was going to be 1 because it's a rotation, and a rotation means that the area doesn't change of the shape; it stays the same. It's just rotated around. So our answer for what this means, that's 1 mark for finding the determinant. Describe briefly how this value relates to the transformation represented by x. The image has the same area as the original. Shape. Okay, the scale factor of the area is 1. So the second mark was for that description there. Okay. Oh yes, thanks Emily.